Parent functions. The 12 basic functions, or parent functions. Many situations in the world that people study and collect data on follow one of the following 12 patterns. By recognizing a general pattern, or what we call the parent function, that can model the situation, and then algebraically manipulating the function, you can almost come up with an exact match. Some people get paid a lot of money to do this. The first 4 parent functions are the identity function, which is a linear function that goes directly through the origin, the quadratic function, which is y equals x squared, or the basic parabola. You have the absolute value function, which is y equals absolute value of x, and you have the square root function, which is y equals positive square root of x. The cubic function is another parent function that we have, as well as the reciprocal function. And we have exponential function, or y equals e to the x, and we have the natural log function, y equals natural log of x. We also have the sine function, or y equals sine of x, as well as the cosine function, or y equals cosine of x. We have the logistic function, and we have the greatest integer function. It's also known as the step function. The identity function, or the parent linear function, is the equation of a line that passes through the origin, and its domain and range are both all real numbers. The squaring function, or the quadratic function, is s of x equals x squared. The domain consists of all real numbers, but then the range of this parent function only goes from 0 to infinity. And it does include 0, since the vertex of the parent quadratic or squaring function is 0, 0. For the absolute value function, we see that it looks like a V. Absolute value of x, you can write it sometimes in a calculator as ABS, and then open parenthesis, and then x in between the parentheses, or you can write it with the vertical slashes and x in the middle. The domain for the absolute value function is all real numbers, and similar to the quadratic or squaring function, the range is from 0 to infinity, including 0, since its vertex is 0, 0. For the square root function, its domain only goes from 0 to infinity, because it begins at the point 0, 0. And then the range for the positive square root function, and notice if there's no minus in front, or if there's no plus or minus in front, it's automatically assumed to be positive. So we're only taking the positive values of the square root of x in this case. And the range of this parent square root function is from 0 to infinity, and we include 0, since the square root of 0 is indeed 0. This parent function is called the cubing function, or sometimes called cubic for short. And whatever your x value is, you cube it to get your y value as your output, or your c of x function. And the domain is from negative infinity to infinity, or all real numbers, and the range is similar, from negative infinity to infinity, or all real numbers, mainly because when you do cube negative numbers, the output value is also negative. Here's a graph of the reciprocal function. When you have the reciprocal function, it is 1 over x, and because the denominator of a fraction cannot equal 0, when you substitute 0 in, it is undefined, or it has a vertical asymptote. And also, since the numerator's power, or exponent, is less than the denominator's exponent, we also have a horizontal asymptote at y equals 0. So that is why the domain consists of all real numbers excluding 0, and the range also, it contains all real numbers excluding 0. If you were writing these in bracket notation, you could write the domain as from negative infinity to 0, non-inclusive, in union with 0 to infinity. And you can do the same with the range. For the range of this function, you can write it as negative infinity to 0, not including 0, or non-inclusive, in union with 0 to infinity. The next parent function that we have is the exponential function. You can write it as y equals e to the x, or you could write it as exp in parentheses x in many calculators. The domain for the exponential function is all real numbers, because there is no limitation on what the values of x could be when you substitute it in there. However, the range of this parent function is from 0 to infinity, where you are not including 0. The next parent function is the natural log function. And the natural log function, or natural log of x, is equivalent to the logarithm with the base of e of x. And the natural log of 0 is undefined. And if you take the natural log of 1, you get 0. Natural log of e is 1, and e squared is 2, and so on. The domain for this function is from 0 to infinity, not including 0. However, the range of the natural log of function is all real numbers. Because we have this vertical asymptote happening at the y-axis, it shoots the function straight down as you get closer and closer, as the x values get closer and closer to 0. So that is why the range is so large. The sine function is our next parent function. If we look at the sine curve, it oscillates between -1 and 1, which is the range restrictions of the function. So the range for sine of x goes from -1 to 1, and it includes both endpoints, since the since the sine of -pi/2 is indeed -1, and the sine of pi/2 is indeed 1. And the domain, since there are no restrictions on how big or small the values of x get, is all real numbers. The next parent function is the cosine function. Just as the sine function, the cosine function oscillates between -1 and 1 for its y values, which restricts the range to be from -1 to 1 and including those two values. And then because it just continues in this wave, the domain has no restrictions or is all real numbers. The next parent function is the logistic function. L of x is equal to 1 over the quantity 1 plus e to the -x. And the domain for the logistic function is all real numbers. However, as you can see within this graph, there is a range restriction, and it only goes from 0 to 1 in y values, not including 0 and 1. There are actually horizontal asymptotes that are occurring at 0 and at 1 for the y values. The last parent function that we're going to talk about is the greatest integer function. And you usually can write it as g of x equals int of x, or you can write it as g of x is equal to the greatest integer function with these extra brackets on either side. And what this does is when you evaluate the function from 0 to 1, when it's in between these values, it always goes back to the previous integer before it. You could think of it as truncating decimals or cutting off the decimal values that you have there, at least for positives. Because if you were to have 1.1, it would go to 1. 1.2 would go to 1. 1.7 would go back to 1. In negatives, you end up rounding down still to the previous integer value. For example, -1/10 is about here. It goes down to -1. And -9/10 is right here, and it still goes down to -1. So the domain for this greatest integer function is all real numbers. However, the range consists of all integer values, which is denoted by capital Z